Hey guys, Miss Cuban here. In this lesson, we're going to talk about independent probability versus dependent events. So, independent and dependent events. I need to make a disclaimer for copyright reasons. I am using Maneuvering the Middle resource, giving the owner full credit out of respect. So, always make as a learning lesson for you students, that when you use someone's resource, always give them respect because it is theirs. It's not yours. So, just want to make that disclaimer before I begin. So, independent probability. When you see the word independent, it should remind you about independent variables. At least that's where my mind goes to. And an independent variable, I know that it doesn't affect another. It is just by itself. I can plug a number in and it doesn't change the problem. So when I look at it as a probability, I'm talking about the exact same thing. It's when one outcome, one event does not impact the outcome of the second event, which is independent. And you can find this out by multiplying the probability of each event happening. So when you see probability of A and B, that means your probability of A and the probability of B. And you're going to multiply them. So let's kind of refresh our memory from earlier. Probability and sample spaces. Sample spaces tells us our outcomes. So if I had my sample spaces of 1 and 2, we had this in the video, and we had our red, our blue, yellow, and orange. In my sample space, I know that I had 2 outcomes for the first event, and I have 4 outcomes of the second event. And when I multiplied them, I had 8 total outcomes. That is essentially the exact same thing as independent probability. But in this case, my first problem, I have 1/2 of getting a 1, and I have 1/4 probability of getting a red. So the opportunity that I'm going to get both a 1 and a red is I would have 1/8, 1 out of 8 chances of getting a 1 and a red. That's independent probability. Okay? Very similar to your sample spaces. So let's try a practice problem. So, let's look. In a board game, students draw a card, replace it, and then draw a second card. Determine the probability of each event. So, I want to earn 50 points. And to earn 50 points, the student must draw a heart-eyed card and then an angel card. So, I notice in the heart-eyed, I have a 1, 2 hearts out of 8. That is heart-eyed. For an angel, there is 1 out of 8. So my probability that I'm going to get both of them is 2 out of 64 chances. That means there are 64 outcomes total, And two of those outcomes gives us a heart and an angel. Let's try another one. To earn 20 points, a student must draw a sleeping card and then an angry card. So, a sleeping card, there are 2 sleeping cards out of 8. But for an angry card, there are 2 angry out of 8. So if I look at my total outcomes of doing both, I notice that there are 64 different outcomes, and 4 of those gives us a sleeping and an angry. Let's try another one. To earn 15 points, students must draw an angry or laughing. So that means in this case, it could be angry or laughing, so it could possibly be both. So I have 1 laughing, but I have 2 angry, so that gives us 3 out of 8. So you are kind of learning that or means to add. I'm putting them together, angry or laughing. And for an angel, there's still 1 out of 8. So your probability is 3 out of 64. And for number 4, a student must draw a sleeping or heart. That means I'm going to add them. So my sleeping is 2 sleeping, 2 heart, so 4 out of 8. And an angry is 2 out of 8. So my probability is 8 out of 64. Now I'm not done because no matter what, I have to simplify. So I'm going to simplify them. Because, hey, if the fractions can be simplified, take it. So 2 out of 64, I can divide by 2, and I get 1/32. 4 out of 64 can divide by 2, and I will get 2 out of 32. Divide by 2 again, and I get 1/16. 3/4 is simplified, but 8/64 goes to 1/8. So, or means to add. I'm going to add them together. But and will tell us to multiply, because I'm talking about one situation and another situation. So let's go with dependent. This is all independent because you're talking about one event and then another. Let's talk about dependent. Dependent events is when the outcome of one event impacts the outcome of another. So looking at these scenarios, flipping 2 coins. If I flip 2 coins and I result on one landing on heads and one on tails, that is independent because the coins aren't affecting each other. The captain of the football team is selected. So I have the captain, and then the co-captain is selected. Now ask yourself, did I put the captain back in to be chosen again? Or did I change the opportunity now? I changed it. So this one would be dependent because I changed the outcome of the second one. I took that captain out and I have a co-captain. The next one. You draw a joker from a deck of cards. So I've drawn a joker. Then I draw an ace. So the first time I drew a joker, which means I was out of 52 cards. But then when I draw an ace, I'm out of 51 because I didn't put the joker back. That is dependent. So basically when you look at these scenarios, when you take something out and you don't put it back, it changes the second event. But as the first one continues, if it doesn't matter and I put it back, then it's not going to affect another one. For example, you draw a queen from a deck, but you replace it, and then you draw a 10. My outcomes didn't change. That's independent. And then if I have a coin and a number cube, those are two separate things, two separate events. They're not changing, so it's independent. So therefore, independent probability is when you take the probability of A and you multiply it by your probability of B to find your total probability. However, in dependent, after I take A out of the problem, I'm left with B after A, which means my outcomes will no longer have A, and I would have to subtract A. Let's try some practice problems real quick, and that way you'll see what I'm talking about. So let's look at number 6. Neil goes to the pet shop and selects a treat for his dog. He chooses one and then chooses another. So he didn't put it back. What is the probability that Neil selects a bone and then a ball? So let's look at our bone. We have 1, 2, 3 bones out of 7. He chooses one of the bones, but he doesn't put it back, so it's gone. Then he chooses a ball. Now I have 2 balls, but I have a total of 6 options. I don't have that 7th option no more. I took it out. So my total probability is going to be 6 out of 42. And when I simplify, that's going to give us 1/7. That's the probability. Let's look at one last one. Mackenzie chooses one candle and then chooses another. What is the probability that Mackenzie selects a polka dot both times? Now, I actually have to write this both times on my paper so that way I know to take one out. So, first of all, I have 2 polka dots out of 5 candles. But I take one away, and now I have 1 polka dot out of 4 candles. So my probability is going to be 2 out of 20, which is 1 out of 10 chance of getting a polka dot both times. I hope this helps explain independent and dependent probability. I would highly recommend that, in summary, we compare and contrast independent versus dependent in a Venn diagram, and I'm hoping to see this in your notebook on the next day of class or when you are reviewing a study, so that you can truly understand what the difference is in independent dependent. I hope you have a great day. Like and share if this helped, and rewatch and rewind if you need more, if I went too fast for you. Bye guys.